Right then, this is your 10.2. We have done up to question number 10 last time. And we have taken a small portion regarding the minor segment. And you know what formula we use in order to find out the area of the minor segment. So area of the minor segment, we use this formula right here. R squared by 2 pi theta by 180 minus sine theta. And before we continue with the rest of the question, I want to give a few hints, few notes on how to find out the area of the major segment. Yeah, let me repeat a little bit. So, okay. So yeah, this green shaded portion, this is called minor segment. Or you can think like this. Look, this is a whole circle, and this line right here, this, what do we call this? We call this chord, right? When you draw a chord in a circle, then what it does is it separates, it divides the circle into two parts. If the chord was passing through the center, then we call it as diameter, right? In a diameter, the diameter divides the circle into two equal parts. These two parts are equal. This part right here and this part right here are equal. But if the chord is drawn somewhere else, right here, or right here, what the chord divides is it divides the circle into two unequal parts. One smaller part is the green shaded portion that I'm showing right here. This part is the minor segment. The smaller part is the minor. And in order to find out the area of the minor segment, what was the formula? The formula was, it looked like this, r squared by 2 pi theta by 180 minus sine theta. So in order to find out the area of minor segment, what you need to know are what is the value of r and what is the value of theta. What is r? You know this very easy. If this is the center, then this radius right here, the length of this radius, how much is this? That's the radius. And what is the theta? What is the angle subtended by this part at the center? So you join the two radii and the angle in between. What do we call this? We call this as sectorial angle, right? So this angle is the angle theta. If you know the value of r and theta, it's very simple and easy to find out the area of the minor segment. And as I told you, this is the minor segment, right? The remaining portion right here. The remaining portion, this portion right here, this is the major segment actually. So there are two segments, one is minor, one is the major. And what is the area of this whole portion? The area of this whole portion is the area of the circle, right? How much is the area of the circle? Pi r square, isn't it? So area of the circle is pi r square. This whole portion is pi r square. Let me just rub off the two radius. All right. The area of this whole circle is pi r square. The area of this green shaded portion, this is the area is this much. If you want the rest, what do we call this? The rest we call it as major segment. So if we want the area of major segment, what we can do is from the whole circle, if I cut off this green portion right here, from this whole circle, if I cut off the green portion right here, then we will find out the area of the major segment, right? So in order to do that, what we are going to do is area of major segment. This will be from the whole area of circle. We will cut off the area of this green portion right here, which is equal to this, minus area of minor segment. Area of circle, you know, it's pi r square. And area of minor segment, it is r square by 2 pi theta by 180 minus sine theta. Look, if you calculate this, if you try to put this into a single formula, then we will have to break this bracket and then open, subtract similar terms and so on, which is going to take a lot of time. All right. So if area of minor segment, if you are able to remember this formula, then area of major segment, what you have to do is from the area of circle, you calculate this first. You calculate the area of minor segment, and then you subtract the area of minor segment from the area of the circle. That way, you are going to get the area of the measure segment very easily. Okay, now let's continue with the rest of the question. I'm picking up question number 12, 15, and the question number 16. So the rest of them, I left it out because they're easy and not very much important from your exam point of view. The exam mostly asks the area of segments, mostly minor segments actually, and questions that are related to sector. All right, so these questions are important from your exam point of view. So let's see what the question number 12 is saying. It says a chord of a circle of radius 6 subtends an angle of 60 degree at the center. Find the area of the corresponding minor segment and major segment. Once we know the area of minor segment, then major segment is easy, right? You just have to subtract from the area of the circle, isn't it? So you have to draw the figure first. So here is your circle. Question says chord of a circle of radius 6. So radius 6 is that of the circle. All right, radius 6 centimeters. So you have got a circle of radius 6. And the chord, it subtends an angle of 60 degree at the center. So if we have a chord here, and if I join them with radius, this angle is how much? 60 degree. Okay, let's draw it properly. This is the chord. Here is your center. You join the two radius. Then this angle right here is 60 degree. How much are the radius? This is 6 centimeter. This is also 6 centimeter. Now question says, find the area of the corresponding minor segment. All right, let's start solution. What is given? Radius is given. It is 6 centimeter. And sectorial angle is given. It is 60 degree. Now time to find out the Roman number 1, area of minor segment. Find out area of minor segment. Area of minor segment will be what? R square by 2 pi theta by 180 minus sine theta. So r square by 2, you put in the value 6 into 6 by 2. Pi, the question says you have to take 3.14. Question says take pi is 3.14. Root 3 is 1.73. So we will put 3.14 for pi, 60 degree for theta, and 180. Minus sine, instead of theta, we will put 60 degree again. So theta is replaced here and here. The value of r is put here on. The others are just part of the formula, right? Okay, few things to do. First of all, you need to know how much is sine 60. You know that sine 60, if you look up at the trigonometric table, it will be root 3 by 2, right? So let's just put a note on the side. Root 3 will be 1.73 as given by the question. It says root 3 is how much? 1.73 divided by 2, and we have got 0.8. 2 is a 16 to 6. So sine 60 is this much value. All right. And the rest of them, we can do a little bit of cancellation. 60 and 180 can be cancelled out. 3 here. 2 and 6 can be cancelled out. Right. So 2 3s are 6. 63s are 180. So whatever is left, you put it down. 3 into 6. 3.14 by 3 minus sine 60 is how much? 1.73 divided by 2. I'm not taking the final value. I'm taking up to here. There is a reason for that. Let's rub it out. All right, time to do multiplication. Multiply this and this. Right, so multiply this term and this term. So what do we get? 3 into 6 into 3.14 by 3. This part is multiplying with this part. This part should again multiply with this one, right? So minus here. 3 into 6 into 1.73 divided by 2. This is multiply with this here. This is multiply with this here. So whatever can be cancelled out, you can cancel it again. 3 and 3. 2 and 6, 2, 3 is 6. What are the values left? 6 into 3.14 is left, minus 3 into 1.73 is left. You multiply them. You multiply them and subtract them. Simple as that. All right, do this first. 6 into 3.14. 6 4 is 24, 6 1 is 6, 8, and 6 3 is 18. Minus, you multiply 1.73 and 3. 3 3 is 9, 3 7 is 21, 3 1 is 3, 5. Okay, final subtraction. So we have got 13.65. And as you all know that this is area, right? We are finding out area. Since we are finding out area, this will be in what? Centimeter square. So you have to put here centimeter square. Right. Okay, the rest up to here, you just have to put the value of r and theta. The rest of them, you just have to do multiplication and subtraction. These are very simple things that you can do by yourself. All right, then. We will take up area or measure segment next. We are done with up to here. Okay, copy here. Okay. I'm keeping the final value only. I'm rubbing off the rest. This part I'm rubbing off. And the Roman number 2 part, it says area of measure segment. Right. Question wants area of measure segment also. And as I have told, this whole portion is pi r square. This portion is how much? This portion is 13.65. The remaining must be from pi r square, you have to subtract this 13.65. Easy as that. So when we want to find out the area of measure segment, we just have to write pi r square, which is the area of circle, minus area of minor segment. Pi r square is how much? It's 3.14 into 6 into 6 minus area of minor segment. We have got right here 13.65. Now after multiplication, we have got 3.14 into 18 minus 13.65. Okay, you multiply this 3.14 and 18. Just to quickly on the side. 3.14 is multiplied with 18. So this side we have got 56.52 minus 13.65. So after subtraction, what you are going to get? 56.52. From here, you have to subtract 13.65. Final value will be 7, 8, 2, and 4. So we have got here 42.87 centimeters square. So you have to understand the concept here. Where is this coming from? There is a formula for measure sector also. R square by 2 something something plus sine theta. You don't need to remember that, all right? If you remember the area of minor segment, it's fine. The rest, the measure segment, area of the measure segment, you just have to subtract it from pi r square. So that's it. Once we have already calculated area of minor segment. This was the value from before. And you find out the area of circle here. Pi is 3.14 is given by the question. And the radius are 6 and 6. Oh, sorry, I made a mistake here. 6 6 is supposed to be 36. So we have got 36 into 3.14. This is 113.04 minus 13.65. So we will get 99.39 centimeters square. Okay, copy this. And remember to copy this on the side when you copy the previous portion of the question, this minor segment, when you calculate it. Remember to copy this part also. This is 12.2, right? Exercise 12.2. The according to the latest board syllabus, 12.3 is not in your syllabus. So we are going to skip 12.3. We will go straight to 12.4 and 12.5. Finished? Is it done?
Yes, sir.
All right. Moving on to 15. Okay, 13 and 14, you try to do it yourself. So 15 says a chord of a circle subtends an angle 60 at the center. So in the previous classes, I have told you all also what is the meaning of subtends. It subtends an angle of 60 degree at the center. Length of the chord is 12 centimeter. Find the area of two segments into which the chord divides the circle. So it's given like this. You are given a circle, and here is a chord. The length of the chord is also given, right? The length of the chord is given as 12 centimeter, right? So the length of the chord from here to here is given as 12 centimeter according to the question here. Question says find the area of two segments. Here is a segment, and here is another segment, big one. Big one is the major, and small one is the minor, right? So question one's what are the areas of this minor segment and major segment? One more thing is given. This angle subtended is how much? How much? This is 60 degree. Okay, something is missing here. If I want the area of the minor segment, right? Area of the minor segment, we have to start from there first. Area of minor segment is given like this: r square by 2 pi theta by 180 minus sine theta. Theta is known, right? This 60 degrees, theta is known. But r is missing. R is missing here. Radius is not given. Instead, it gives length of the chord is 12. This is 12. What we want is we want from here to here. We want the length of the radius. Okay, how to do this then? Let's name it A, B, C. Now we will draw a perpendicular. Let's remove the 60 degree here. We will draw a perpendicular like this. Let's name it as D. And as you have already learned in class 9, what this perpendicular will do is it will divide BC into two equal parts. Okay. BC used to be 12. This whole thing is 12, right? Now, when you draw a perpendicular AD, this part right here and this part right here, they will be equal. We will get two equal parts. So if I divide the 12 into two equal parts, what will each be? From here to here will be 6 centimeter. From here to here will also be 6 centimeter. So BD is 6 now. This is 6 now. This is also 6 now. And AD, it will also bisect this angle. This whole angle, it will be bisected, meaning this angle, whole angle, it will be divided into two equal parts. How much was it? It was 60 degree, right? So this 60 degree here, it will be divided into two equal parts. So we will have 30 degree and 30 degree on each side. Okay. So this is 30 degree. This is 30 degree and this is also 30 degree. What does this AD helps? What does it helps is, this is a right angle triangle. Let me draw down here. I'm drawing only one part of the triangle. Okay, there are two triangles in there. This part right here, I'm drawing it separately. ADC. So I'm drawing it a little bit bigger. This is how much? This is 30 degree. DC is how much? 6 centimeter, because we have divided 12 into two equal parts. What we wanted? We wanted AC. We wanted the radius, right? So with regard to this 30 degree, the opposite is known. We want the hypotenuse. Opposite is known. We want the hypotenuse. So opposite and hypotenuse, which trigonometric ratio has opposite and hypotenuse in it? Sine, right? So we will use sine 30 degree and we will have opposite by hypotenuse. Sine 30 is known, opposite is known. We can find out hypotenuse very easily. Okay, that way we will calculate the radius and then we will find out area of the segments. So a little bit of a trigonometry in here also. If you don't understand trigonometry, no solution for you, no understanding for you from this question number 15. So let's begin the solution. Solution. is given. What is given? The chord is given as 12 centimeter, but we name them as BC. BC is equal to 12 centimeter is the chord. What about the rest then? We are given the angle theta as 60 degree. Angle theta is which angle? This angle right here, BAC. So we will write angle BAC is equal to 60 degree. Now, in order to find out the radius, we draw a perpendicular AD. Perpendicular. This AD is perpendicular to this BC. So you have to mention here. We draw AD perpendicular to BC. What did the AD do? AD, it divides this whole BC into two equal parts, and it also bisects this angle 60 degree into 30 and 30. So you have to mention here AD bisects BC and angle BAC. So BC is divided into two equal parts, angle BAC also. Angle BAC is also divided into two equal parts. So you take this triangle right here in triangle ADC. What is what? DC is how much? 6 centimeter. Angle DAC is how much? 30 degree. So this is 30. This is 6 centimeter as mentioned. We want this AC, which is the hypotenuse. So you start sine 30 degree. This is opposite by hypotenuse. Opposite of 30 degree, this is the DC part. Hypotenuse is the AC part. Sine 30 is half. DC is 6. AC, we don't know. And if you cross multiply, we are going to get 12 centimeter. So AC is 12 centimeter. In here, what is AC? AC joins the center and the part of a circle, point in a circle. AC joins the center and the point in a circle. That means this is the radius. Of course, you can use this triangle also. You can draw this triangle separately here. A, B, D, and then you can do the same thing. But you will still obtain the same value of this AB also. You will still get AB as 12. Therefore, how much is radius? So radius is 12 centimeter. Angle theta, the central angle or the sectorial angle is 60 degree. Now we can find out the area of minor segment very easily. Can you copy up to here first? Now, since we have got the sectorial angle theta and the value of radius, yeah, we have got R is 2. Theta is how much? 60 degree. We are not taking the half angle. All right, we are taking the whole angle right here. So, what is the area of minor segment? You know, this is R square by 2. Pi theta by 180 minus sine theta. So R is 12. So we will have 12 into 12 here. Pi theta by 180. We will put 3.14 into theta is 60 by 180 minus sine 60. So 60 and the 180 we can cancel them out, right? 63s are 180 and the sine 60 is root 3 by 2, right? So 12 into 12 divided by 2, we have got 3.14 by 3 minus root 3 by 2. Okay, a small cancellation here again. 2 6 are 12. Okay, wait a minute. So 2 6 are 12. What is remaining? 6 into 12 is remaining, right? Outside. Inside, what is remaining? You divide them 3 and we can put this as 3.14 by 3 minus 1.73 divided by 2. So 6 into 12, do cross multiplication, 3 to the 6, 6.28 minus 7 by 21, 313. Okay, what do? We multiply 3 and 2 first, we have got 6. We do cross multiplication. 3.14 into 2, we have got 6.28. 3 into 1.73, we have got 5.1. And this 6 and this 6 can cancel out again. So what is left? We are left with 12 into, subtract these two right here. So we have got 6.28, 5.19, 9, and there is 0. We've got 0 point. There is no still. Oh, there is 1 here. There is supposed to be 1 here. So final value 12 into 1.09. What will be the value? Just multiply them. I'm going to use calculator for quicker. So we have got here 13.08 centimeter square. So that's the area of the minor segment. I'm giving you major segment. We have already calculated one question that is related to major segment, right, previously. So it says 2 segments. You have calculated minor segment. The major segment part, you have to do it yourself. See if you can do it. All right. Okay, copy this. All right, moving on to 16. Okay. So 16 is a little different. It contains an equilateral triangle and there is a curve involved also. All right, then let's read the question, what the question is saying. A grass field, there is a grass field which is in the form of an equilateral triangle. All right, equilateral triangle of side 48 meter. Hello, we have got an equilateral triangle. We have got an equilateral. This is a little bigger. We have got an equilateral triangle. Equilateral triangle means all sides should be how much? They all should be equal, and all the angles should be 60 degree. That was the property of an equilateral triangle, right? So the sides of the equilateral triangle, it is given to be how much? It's 48 meter. So if you take this side, if you take this side, this is 48. This is 48, this is also 48. So all sides, 48 here, 48 here, 48 here. Question says a cow is tethered at the vertex of the field. So these top points, these are called vertex, right? So let me, one cow is tethered here. One cow is here. And if the cow can reach up to 21 meter from the vertex, how much can it reach? It can reach up to here, up to 21 meter. Total is how much? Total is 48. So the half will be 24, right? So 24 here and another 24 here. So half will be here, which is 24. And without reaching 24, it can reach up to somewhere here, which is how much? How much distance? 21. And the question was, find the area of the part of the field in which the cow can graze. The cow can graze up to this part only, right? If it goes, since it is tethered to a rope, since the cow is tied to a rope, what's going to happen is it can go as far as 21 meter only. It can go as far as 21 meter only, and the remaining part are not filled. So it can go up to this part. It can go up to this far only. The 21 meter, 21, 21, 21. And how much area remains ungrazed? This remaining area is ungrazed. The cow cannot reach here, so this part is ungrazed. The cow cannot reach this part right here. And the increase in grazing area if the length of the rod be increased to 35. I'm going to give this as homework. All right, this is homework for you. 1 and 2, I'm going to do it right now. So first of all, let me name the field as ABC. A cow is tethered at B and it can go as far as how much? 21 meter. So it can go as far as 21 meters. So 21 meter here. Okay, so the part where the cow can reach, I'm going to shade it like this. This green part is the only part where the cow can reach, right? So what does it look like? It looks like a sector, right? It is a sector actually. Sector of a circle. Sector of a circle having radius how much? Having radius 21 meter. And the angle of the sector, this part right here, since it says the triangle is an equilateral triangle, this part right here, it will be 60 degree. Get it? So this part right here is 60 degree. So here, let's start the solution. So the part where the cow can graze is in the shape. All the angles are 60-degree because it's an equilateral triangle of an equilateral triangle. Sorry, is in the shape of a sector, right? Of theta is equal to 60-degree. Radius is equal to 21 meter. So this green part is the part where the cow can graze. We have to find out the area, so that means we have to use the formula for area of the sector, right? So you mentioned here area which the cow can graze. How much is it? Pi r square theta by 360. This was the area of the sector as we have done in earlier portion of this exercise. So you can use 22 by 7. R is 21. Theta is 60. Cancel 7 3s are 21. Let me do it. Great. 7 3s are 21. 66 are 360. 3 2s are 6. 2 11s are 22. What are left? Look. 11 is left. 21 is left. So final is 11 into 21. We will have 1, 3, 2. Okay. This much the cow can graze. All right. What about the remaining portion then? Remaining portion, the question asks, this is for Roman number 1. This is for Roman number 1. It says, how much area remains ungrazed? This is the part where the cow cannot graze. The cow cannot eat the grass in this portion right here. The only portion the cow can eat the grass is this green part. Rest of the part, because of the short length of the rope, it cannot reach it as a whole. So remaining part, how to find it out? Simple. First, you find out the area of this equilateral triangle. And then you subtract this part. You subtract this part, subtract this green part right here. The green part, we have found out this portion. So if I want to find out the white part, the part where the cow cannot reach, you have to find out the area of triangle first. And then you subtract this portion right here. Area of triangle is easy because we know the area of triangle formula, area of an equilateral triangle. Okay, copy up to here. We will come to the Roman number 2 part. Proper diagram is always necessary. We have to keep this in mind. Geometry, mensuration, and of course trigonometry. You have to have proper angle, a proper drawing, proper diagrams in there. Otherwise, in trigonometry, if you don't have the diagram, then no marks. The examiner will know that you have copied it from somewhere else. Okay, now you have to find the area of the triangle first. Okay, in order to come to Roman number 2. Let me just keep the 231 part only. So if we come to Roman number 2, then you find out the area of triangle first. Area of triangle, what's the name of the triangle? ABC, right? This is the fill actually, so you can say fill here also. It's an equilateral triangle, so we have a formula root 3 by 4 into side square. Root 3 by 4 into side square. So we have the side. We know the side. The side is given here. The side is given as 48 meter. That means you can put here root 3 by 4. Side is 48 into 48. Cancel them. 48 4 into 48. We have got 12. Then the remaining value is 1.73 into 12 into 48. So root 3 is 1.73, 12 is here, 48 is here. So after multiplication, this is going to take very long. So I'm just going to use the help of calculator. So 1.73 multiply with 12 multiply with 48. So the value is actually 996.48 meters square. The whole fill is this much. Out of this, the cow can reach only this portion right here, right? How much is this portion? This portion is 231. How much is the remaining then? You have to subtract this too. So you have to say here, area ungrazed. You have to subtract 996.48 minus 231. Sorry. Okay. So how much is this? 996.48. 231.00. So 5 6, 7 here. So this much is left ungrazed. Okay, this much, this whole portion, the area of this portion is the ungrazed part. So from this whole area of the field, we subtract the portion where the cow can reach. Okay, copy this and then we will finish for today. In the next class, I'm going to take up questions related to volume, which will be from your exercise 12.4. Yeah, 12.3, we have to skip it. Okay, then let's finish here for today. We'll take up exercise 12.4 and related formulas and everything else in the next class.